So hello everyone, hope you're doing good and welcome back to my channel. Today we are at day 17 of the June daily code challenge and we again have a hard level question of us. Yesterday also we had hard level question. And before that we had mostly questions of medium to easy level. They were mostly on, either direct programming or array based or related to trees, especially binary search tree. Yesterday also we had a question on binary search tree. And today we'll be looking at a bit different topic. It's again on arrays. Let us see what the question is. It's question 1187. Make array state increasing. Okay. We'll talk in depth about what is the meaning of settle increasing, and then we will see examples, and then we'll try to understand how to solve this question. Okay. So, given two integers arrays array1 and array2, as you can see, there are two inputs given here. Both are integer arrays array1 and array2. Okay. You return the minimum number of operations. Okay. Needed to make array1 steadily increasing. I will again repeat. Return the minimum number of operations needed to make array1 steadily increasing. So we are only talking about array1 here. Okay. Now where do array2 comes into picture? We will see that now. Okay. They are saying, see, here we're talking about number of operations, but what is operation is still not defined. Okay, so here we're defining that in one operation you can choose two indices I and j. I is from the array 1, j is from the array 2, and do assignment. So what it means is, see, the idea here is you can replace one element of this with an element of array 2. That is a very simple idea. See, whatever the meaning, see, whatever terms I've used here, they only try to mean that you can replace any element of array 1 with any element of array 2. They need not have same index. Any element of array 1 can be replaced with any element of array 2, and that is being called as a operation. Okay, so whenever you do that replace thing with any element of array 1 with any element of array 2, it's being called as an operation and it's counted as an operation. Okay, and ultimately you have to return the minimum number of such operations equal. Okay, to make array still increasing. What still increasing? It's definitely depending for me to explain you, but just understand there's something called still increasing. For we have to ensure that it happens, and for that we are allowed to do some operations. What operations? Operation means any element of array 2 can replace any element of array 1. Okay, for any one element of array 2 can replace any one element of array 1. That's called one operation, and after that if you change again, then it will be counted as second operation and so on. Okay? If there are no ways to make array 1 settling grazing, return -1. Okay, so that is the basic idea. Now come to what is settling grazing. See here, if you see in this example, see it's written as 153367. Okay, so if we replace 5 with 2 as I'm mentioning here, we replace 5 with 2. From where 2 is coming? 2 is coming from array 2. Okay? Any element of array 2 can replace any element of array 1. So if you replace it, becomes something like that. Okay? You can say it's called strictly increasing. Why it's called strictly increasing? See, strictly increasing means it's increasing. At the same time, it's strictly increasing. That means, see, for example, if I have a 3 present here, okay? So 1, 3, 3, 6, 7. So two elements are getting the same. Okay? If suppose 3 is present here, then this is also 3. In that case, it can't be called strictly increasing. Strictly increasing means there should definitely be increase from when we go from one element to the next element. Okay, that is the basic idea of strictly increasing. There should definitely be increase. It cannot be the same. As simple as that, it cannot be the same. Okay, that is the basic idea. In this example, you can see if we replace 5 with 2, we are solving this question. Okay, now in this case, see, so we are doing only one replace, so the answer is 1. Okay, number of operations is 1. Now come to this case. See here, it can be replaced with definitely not 1 because this itself is 1. Okay, so definitely not 1. So we can talk about 3 here. Okay, so we can replace 5 with 3. Okay, that is done. Now see, if this become 3, so 3 and 3 again it's not possible. 3s and 3s cannot be consecutive of each other. So this 3 needs to be replaced with a 4. Okay, so it became 1, then 3, and then a 4. Okay, 1, 3, and a 4, then 6 and 7. So basically, we're doing two operations. We're replacing 5 with 3 and replacing 3 with 4. So there are two operations involved. And so, yeah, that's two operations. And similarly, in this case, you can see we cannot make 5. Uh, See here, you can what you can replace with. See, either we can replace with threes, but if you replace with threes, threes and threes cannot be consecutive. That is the basic idea. Anything else you cannot replace here, so it can't be strictly increasing at any cost. So we have to return -1 here. Okay, so that was all, friends. Now coming to how to solve this question. Okay, so we are again going to solve it using the dynamic programming approach. So we are defining dfs of 1 is equal to the minimum number of operations needed to make the subarray starting from the ith index sorted. Okay, dfs of I is equal to minimum number of operations needed to make the subarray starting from the ith index as sorted one. Okay, so see there are two cases possible now. Okay, if array array 1 of I is greater than array 1 of I minus 1, that is ith element is greater than I minus 1th element. So okay, we have two possible options. See, ith element is greater than I minus 1th element. Okay, that's a good sign. Okay, so first thing we can do is leave it unchanged. Continue with the next index. Okay, another option is replace it with a smaller index. Okay, why? we'll see that now. But remember why please focus on this step. See, the ith index is already greater than the I minus 1 index. Okay, still we can replace it with a smaller number. Okay, why it's needed? See, here the significance of it. Step 2 can make it easier to ensure that subsequent numbers are greater than array of 1. That is the ith element of array 1. Okay, so it will help in ensuring that they are subsequently greater than that. We'll see that in examples. First, let's talk about this element. Okay, you can see 1 and 2 are following that still increasing rule, but then after 2 we have another one. This is not following that. So what we have to do is we have to replace this element. See, this is the array 1, this is the array 2. What we'll do is we will search a number greater than this. That is the previous of this. That is, see, 1, I'm currently at I, which is this 1. Okay, ith index, which is the second index, which value is 1. What I will do is I will try to search for element in array 2 which is greater than my previous element of this current number. Okay, so which will be greater than 2. So what we can do is I can yeah, the in narrative you see the number greater than the previous element, which is 2, is 3. Okay, so we can replace 1 with 3. As you can see, we are doing that with 3, and then we can proceed further. That is one idea. Now coming to the second scenario, you can see here 100 is anyway greater than 2. Okay, in this case, all of them are strictly increasing till now. But remember, 100 is a really bigger number compared to 2. Okay, so what we can do is we can replace it with a slightly smaller number. That is, again, we are going to search a number in array 2 which is greater than 2. Okay, so in this case, it will be 3. So if we search, replace it with 3, it will make my task easier to ensure that the rest of the array is still increasing. Okay, suppose we have 4 here next, then it will be still increasing. But remember, after 100 if 4 comes, it won't be still increasing. So that is the basic idea. If we have two scenarios in which we compulsorily have to make a change, we have to replace, that is, the operation is needed. But in this scenario, operation is optional, but we do not know what is lying ahead. So we have to consider other scenarios also before doing this. So these are the two scenarios. I will definitely recommend you to pause the video once, rewind it and play it again, because these two scenarios are really important, and these two scenarios are going to be major part of my coding. Okay. Now coming to the coding part, we are going to see these things are optional. Okay, I will come to this later. See these things, and yeah, here also these things are slightly optional. This is just caching with memoization. If you have seen my previous videos, you will notice these things are optional. This will help you increase the time efficiency of your program, but again, these are optional. Okay, option in the sense for solution. I'm not saying that if you remove it, answer will get accepted. It may not be accepted because of long time complexity. Okay, so we'll come to that later. But first, see now. Okay, first, in order to ensure that we get the arrays, that is number greater than my previous number, I'm first of all going to sort the array two. Okay, only when array two is sorted, it will be easier for me to do a binary search on it. Because see, as I showed you in the example here, I need to find a number which is greater than its previous. That is, I need to find a number which is greater than 2. For doing that, I will be using the binary search approach. So that is the basic idea. And yeah, we are defining the DFS function here. And this will be my recursive function, and this is how I'm going to implement the DP. And so here, basically, there are two things. First thing is the current index I for which I'm going to consider, and the other thing is the previous number. See, remember there are a difference. This is the index, and this is the previous value. So these are the two things which I'm going to take as the input to this function. Okay. Yeah. Now coming to what we are passing. See, for the first element there is no previous. Okay. So see, this is the zeroth element from which we are going to try, but there is no previous for it. Okay. So what I will do is I will pass simply a -1. Okay. But see here they are clearly mentioning that things are going to be positive, right? The values are going to be positive from 0 to this. So passing a -1 will ensure that I don't make any change to that. Okay. So that is the basic idea. So for every number, that is why with as index, its previous value will be passed here. Okay. Now, come see now. This is these are some of the base cases. Okay, this is a base case where if I is equal to the length of the, that is I crosses all the possible elements. That is, see, for example, any array will have the range 0 to n-1, where n is the length of its array. Okay, so when I becomes 10, that is, it has crossed all the elements. Okay, in that case, I have written 0. Okay, that is the base case. These are DP cases, DP related cases. I will come to that later. But what it means is, if see what we are doing is basically, let me try to explain you this. We are see this thing, we are going to cache it. Okay, the index and its previous number, we are going to cache it. Okay, so what will be the key will be the current index and its previous value. I'm going to cache it in a DP. And what will the value stored in the DP will be the cost of it. What is cost? We have not seen that till now, but we'll come to that. But just remember one thing: in this DP, I'm going to cache the these values, okay, whatever values I'm passing the function at, this will be cached, okay, so that we don't recalculate things which have we already calculated. So once we suppose we have calculated something, how we'll know that we have calculated? See, this based on this. See, all calculations are going to happen based on these values, okay, the ith index and its previous value. So if this index is already calculated, I'll save its value in a DP. That is, its way of caching it. For the key I comma previous, we are going to show the value as its cost. Cost means the total number of operations needed from that onwards. Okay, that is the basic idea. See, I have already mentioned basically what is the DP of it. Okay, so yeah, sorry, the difference of it. Yeah. So what we say, this is the cost. Initially, I'll keep the cost as infinite. Okay, why we are keeping infinite? The reason behind that we'll see that later. See here we are using that infinite. What is that? I will come to that later. But just remember, this is in Python's way of ensuring that we keep it the maximum value possible, right? It's Python way of ensuring that. So this is the most maximum possible floating point value, right? Next thing is we are going to check if previous is past year, right? Previous is past year and the index of the current value is past year. So I'm just checking if the value of the current index is greater than or equal to previous. Okay. If it is greater than or equal to previous, then valid and good. Okay. So valid and good, but cost will change here. Remember, cost initially was infinite, but cost will change here. That is, cost will be equal to now the next step of it. What's the next step? See, I'm going to I plus one value, and I'm passing the current value as the previous of the next index. Okay. That is the change. Remember, this condition need not be true. Okay, as we saw in this example, here in case of one, this value need not be. This condition won't be true. Okay, because two is greater than one, right? So I is basically smaller than the I minus one value. Okay, that is basically in that case won't be true. In this case, float will remain as a a larger value, a greater value. Okay, that is the basic idea. But if this condition is true, we will get a value here. Okay, so the idea here is, see, as we explained, even if the value is greater, we'll still try to search for a value in the array 2, which is smaller than, you know, see, slightly greater than the previous value. That is, in this case, 100 was the previous value 2. We'll try to find out slightly greater than 2 using the binary search. Okay, that's what we are going to do next. Remember, this condition is optional. Again, repeating this because you will find difficult if you try to understand on your own. Okay. So if the current number is greater than its previous number, this condition will be true. We'll have some decent value for cost. Okay. But if this condition is not true, that is the current ith index is not greater than I minus one index, we'll have infinite value for the cost. Okay. That is, it's not possible to solve further. Okay. Now we will try to find. We will try to use the array two now to find a number which is slightly greater than the previous number. Okay. So whenever we see this bisect function, so basically we are trying to do a binary search here. Okay. And we are going to do a binary search in this array two, and we are trying to find a number you know in this previous way. Okay, that is we are trying to find a number which is slightly greater than the previous one. Okay, and its index will be idx. So see, this Python function, basically we'll have to import this function and run it if you are trying it in a local compiler. Okay, in Leetcode these are things are already imported, right? So you can use it directly. It's Python way of using binary search. I'm again repeating this. If you're doing a C++ thing, then definitely this function won't be there for you. You'll have to find a similar function for binary search. Okay. So what we're doing in array 2, I'm trying to find a value which is greater than previous value, and its index, if it exists, will be a different decent index. If it doesn't exist, then it will be the last index of the array. Okay. So I'm checking if this value is a legal value or not. Okay. If index is less than the all of the length of the array 2, then it's a legal value. Otherwise, it won't be legal value. If this is the legal value, that means if there is a number existing, see this case will is coming now. See, 100 is definitely greater than 2. That means a good sign. But still, there are numbers which we can replace with 100 so that its value is slightly decent and it will help us further. Okay, so that's what happening here. Now cost will be the minimum of the previous cost, comma 1 plus what 1 means 1 ensures that we are doing operation, right? What is that operation? Because see, we have found a value which is just greater than the previous. See, this is what is happening, right? 100 is increasing, 100 is greater than 2, but still 3 is again greater than 2. So replacing 100 with 3 is, see, it's an optional option. Okay, you need not do it again and again. You need not do it also. That's why here there are two kind of cases coming. Either first case is when we are simply going forward without doing any operation. Okay, I'm simply going to I plus one index and not doing any operation. Other cases, I am doing an operation where I'm adding one. Okay, I'm adding one here, and then I'm doing a difference of the I plus one value. But remember the array which, sorry, the element, previous element which I'm going to pass now is array 2's index. Okay, array 2's idx. Okay, not array 1's idx. Array 1 I. Okay, it will be array 2 of idx. Okay, that is the only difference here. So it will be meaning of the two. Here this ensures this case. Okay, this ensures this case that where we are not doing many change. At least 100 will go as it is. Okay, and the other cases we are replacing with a you know greater value from this previous. See, we are only using previous. That means we are only trying to find a value based on the just 2. Okay, a value greater than 2 here in the array of 2. Okay, we're not using 100 at all. So that is what is ensured is this. We are trying to go to I plus 1 value, but we are in the previous value. We are passing uh, the index of the value in array 2, which is greater than the previous value. Okay? So from where previous is coming, previous is coming from here. Okay, this is the basic idea. This is called cost. So you can see there are 3 assignments to cost. Now this is the first assignment. This is the second assignment. If this happens, if current index is greater than previous index, and this is the third assignment. This ensures that even if the ith index is greater than the previous index, still we are trying to find a value which is still better than that. Okay. Remember, we are taking minimum that. That is, see, if we take this operation, that is, if we replace 100 with 3 or not, depends on the values after 100. Okay, that's something in the future. Okay, that's why we don't know that currently. So we are taking the minimum of that. Okay, remember, please read the reference of defense again. It refers to minimum operations needed to make the subarray I till the last layer. Okay, so we don't know the last now. So this will continue further. Once it returns all the values, see this will return. See, this is the base condition. This is where the defense function will end. Okay, when we reach the last index, from there it will return 0. Okay, so here it will be written. So the idea here is it will work in a top-down approach. Okay, we're starting from the top, we're going to the bottom. Okay, it's like a recursive call again and again. So here we're making a recursive call. Okay, and finally, whatever is the cost, I'm trying to cache it. Okay, this is how I'm caching it. The key will be I comma previous. That is this value, exactly this value. I'm going to cache it here. Okay, I'm going to cache it, and then I'm going to return the cost. Remember, this is how it will function. If this calculation is already done, then it will be stored here, and this will be directly returned. That is the basic idea. Remember one thing: if possible, that is, if for example, here we did replace 100 with 3, or come to this case, we replace 1 with 3. If such a replace is not possible, okay, what will happen? This value will remain. Okay, cost will remain as infinite only. Okay, so that's why, see, we are going to call this difference function on the 0th index and passing the previous value as -1. The answer will be stored in res. Then we are checking if res is less than float of infinite, that is, if it is having a decent value, only then we will be returning res. Otherwise we will be returning -1. Okay, because if the cost remains as the float of infinite, that means a valid solution is not possible. We cannot do a replace such that array 1 becomes still increasing. That is the basic idea. And finally we are returning the value if we are getting, if it's not a float of infinite. So that is what is being done here. Okay, as I told you, this is float of infinite. This will be returned in case there is no possible replace possible. So there's no replace possible such that array 1 can be made as steadily increasing. So that is what is it. Okay, so yeah, friend, that was all. And see this part, this caching part, this I am storing the caching, and this is where I'm utilizing the caching. Okay, these things will improve your time complexity. See, this kind of DP solutions, if you don't use caching, this won't be feasible to run it. And most compilers, sorry, in the test scenarios, online assessment, this won't be appreciated as well. Okay, so caching will improve that your time complexity, improves. Okay, because we are not, avoiding the recalculating things which are already calculated. So yeah, friends, that was all for today. If you have any doubts, please do comment below, and we can discuss further. Thanks a lot. See you tomorrow.